When you purchase any product from the Amazon, you need every notification on real-time basis. You order some food, you want to track where the driver has reached. Real-time data streaming is everywhere. These days, we want everything in real-time basis. But we did not start with this. In early 2000, when the internet started booming, a lot of new people started getting access to the internet. At that time, the volume and the speed at which the data was getting generated was very low. But due to rise of social media and other applications, more and more people started getting access to the internet, and the amount of data that was getting generated grew. But it was not just about the size of the data, it was also about the speed at which the data was getting generated. The businesses want to understand this data so that they can understand what their customers are doing and provide the better services. At that time, we used to use the batch process to process our data into different chunks on weekly or the daily basis. This is good for the analytics, but what if I want to process or take actions in the real-time basis? For example, if there is a fraud transaction happening from your credit card, you need a real-time system that can detect this fraud and also send you the notification so that you can take some actions on it. We did not have anything. There was a need for real-time data system that can provide this kind of services, and at that time we had some system for that. Companies used to use tools like RabbitMQ or the transactional databases. These systems were very good for the smaller type application where the data volume and the velocity of the data was low. But as the amount of data grew, they struggled to keep up with the real-time demands of the modern large-scale system. Latency and the bottlenecks of the data were the constant challenge. Team used to spend a lot of time understanding and keeping the system running just to process all of these data. And also, as the data grew, this system couldn't keep up with the demands, and we needed something better here that can process all of these data on the large scale. The industry needed something more robust, scalable, and capable of handling streaming data. Enters Apache Kafka. In 2010, LinkedIn, a professional networking website, was facing similar challenges. Their platform was growing at the rapid pace, generating massive amount of data every second. They needed a system that could handle the real-time data and also process them in the distributed manner, like onto multiple machines so that they can process all of these large-scale data. This led to the birth of Apache Kafka. Kafka was created by the LinkedIn engineers. They were inspired by the need for a robust, distributed system that could handle vast amount of data onto the real-time basis generated by the LinkedIn users. The Kafka was designed from the ground up to be a distributed streaming platform. Architecture allowed you to handle the high throughput, low latency data streams and make the ideal solution for the LinkedIn challenge. So in 2011, LinkedIn open source code for the Apache Kafka under the Apache Foundation so that everyone in the world can use Apache Kafka for their system. Companies across the world started using Apache Kafka, from logging to monitoring for event sourcing and stream processing. Today, Apache Kafka is used by all of the top companies to process the real-time data streaming. Every application that you see in the world uses Apache Kafka or the similar system to process the real-time data that you generate. So let's start by understanding what is Apache Kafka. In simple terms, Apache Kafka is a distributed streaming platform. It allows you to publish or subscribe to a streams of record similar to the messaging system. So on one hand, you can send a message, on the other hand, you can consume that message. But you might wonder, this is a very simple problem, right? I can just send a message from one end and retrieve it on the other hand. Why do I need Kafka in between? Well, you can do this thing on a very small scale. So if you just want to send a message and receive it from other end, this is a very simple problem. But if you talk about billions of events that is happening around the world, for example, Instagram, they have billions of things going on their platform. How do they handle the large scale data, velocity or the speed at which all of these data getting generated? We need a distributed streaming platform that can process all of this data into parallel, that you can also send easily and also retrieve it on the other hand. This is what the Apache Kafka is capable of. Apache Kafka can handle high throughput real-time data streams with the scalability, reliability and the low latency. High throughput means to process the large volume of data quickly, and Kafka can do that. So the Apache Kafka's architecture has three main components: producer, consumer and the broker. Let's start by understanding the producer and the consumer. Producers are the source of the data, pushing the records into the Kafka topic. So when you like something on the Instagram or when you comment something, all of these things considered as a producer because the data is getting generated. On the other hand, we have the consumers. Consumers are the people who basically consume this data to do something about it, basically take the right actions or analyze all of this data. So in this case, if you are a data engineer, you will consume this data, you will process as per the business requirement and then publish this data to a data warehouse or some kind of storage system. Now we publish and consume all of this data using Kafka topics. You can consider topics. Topics are basically the categories or the feed names. So in case of Amazon, we can create the multiple topics. For example, one topic for ordering of the the product, one topic to get the data about the returns of the product, one topic for the shipping. All of these are the different categories of the topic that we can create to separate our data logically. So in one case, we can publish the data to that particular topic, and on the other hand, if someone is interested in getting the data about the returns of the product, they can subscribe to that particular topic and they get the data about it. Now on top of that, you can also create the different partitions inside the different topics. So let's say if you want to partition by the different dates or region, you can also do that into the Kafka. So if someone is only interested into the particular region, they can just get that partition of the data and process this data as per the requirement. After this, in the architecture, we also have the brokers and the clusters. A Kafka broker is a server that stores data and serves the client request. So it can be like a single EC2 machine that you are running. You can consider it as a server or a broker, and the combination of these multiple machines can be considered as a cluster. And when you have multiple brokers working together, it becomes a cluster. So having a multiple brokers running ensures the high availability. So in case one broker goes down, other can pick it up and keep the system running. On top of this, we have like different concepts available. Important ones are the partition and the offset. We also have the concept of partition and order inside the topic. That means each partition in the topic is ordered and the immutable record. This means once the data is system, you cannot modify it. It is immutable. Each record in the partition is also assigned a unique offset. That basically means the position of that particular record inside the partition. So it is like this. Inside the server, you send a message using a producer. It is sent to a specific topic. Inside the topic, we are creating a different partitions. It can be based on the date or the region, and inside that we have an offset. You can think it like an ID or a number where your records are stored. So using offset, you can track the record position in the stream and ensure that you process each record exactly one. Let me just show you this particular thing hands-on so that you understand it better rather than just talking about the theoretical side. First, what you need to do, you need to go to this particular URL, docker.com Docker desktop. You just download the Docker for your local PC because this makes installation of Kafka much more easier. Once you have it installed, what you can do, you can see this Docker compose file. You can download it from my GitHub repository. All you need to do is just put this onto one folder, and this Docker compose puts the Zookeeper image and the Kafka image, and it will set up the Kafka in your local PC onto this particular port 9092. Okay. Once you have this, you can go to the terminal and navigate to the folder open in the terminal. On this folder, you will see I have the Docker compose YAML file available. This you have to download and put onto your local PC. Then after this, I will run the command docker dash compose up. This will run the entire YAML file that we created for the Docker compose, and it will set up the Kafka in your local PC. Once you have this running, what you can do, you can either open the new terminal or the new tab. In my case, I'll just open the new tab, basic. Onto the same folder, I'll just write docker ps. You will see we have the Zookeeper running, okay, and we have the Kafka running. So these are the two containers that are running in my PC. Now what we can do, we can log in inside one of the container and create the producer and the consumer code. So what I will do, I'll just open the new window, okay, with the basic profile. So this is the new terminal that I have. Over here, I'll do first docker ps and get the container ID. Okay, I'll copy this container ID and then I will write docker execution interactive environment. I'll paste the container ID /bin/bash. Okay, what this will do, this will log me inside the Kafka container so that I can run my producer and the consumer command. First of all, as you understood, we need to create a topic. So all of the commands are available here. To create the topic, it is very simple. You have to navigate to the Kafka libraries. So I can just go here. If I do ls, you will see all of the libraries are available. You can start the Kafka server, you can stop them, you can create the consumer, producer, everything is available. First, I need to create a topic. So creating a topic is pretty simple. You can do it on terminal and also you can do it on programmatically. So I'll just use the Kafka topics. I'll add a create topic. This is the topic name. This is my server information. Replication factor is 1 and partition is also 1. In this case, we'll only work with the one partition. So all you have to do is just copy this and paste it over here. Now, this will create a one single topic inside your container. Okay, as you can see, topic 1 already exists. In my case, I already have this, but in your case, it will create a new topic from the scratch. If I do clear, okay, this will clear the entire screen. And now what I can do, I can create and publish the messages inside the topic. So I can use the producer over here and I can just paste this command. This will enable the producer so that we can send a message over here. Okay, so this is our producer is running. As you can see, there is a one message sign available over here that you can use to send a message. For example, I can send my name, I can send whatever I want over here. Now we need a consumer who can consume this message. So this is the terminal for my producer, and this is where we will run our consumer. So what I will do, first I will also have to do the same thing, docker ps. I will get the container ID and I will log in inside my container which is docker exec-it. I'll paste the container ID /bin/bash. Okay, I'm inside the container. I will go inside this folder which is opd kafka bin, and then I can write the consumer over here, which is this one. Okay, I'll get this, and this will run the consumer server for us. So as you can see, these are some of the previous messages that I sent. I can send more messages such as, let's say, my name, and if I show you, you will see all of these messages will come here. I can send whatever I want, and you will see all of these messages are coming. Now what is happening inside is that we are producing some messages from the producer, sending that to the Kafka server that is running onto this particular port. Okay, this is what we call as a Kafka broker, where this is the server is running, and then we are able to consume this message. So it is pretty simple. You send the message from one end and you retrieve the message from other end. Now what I can do, I can do this same thing using programmatically. So this is the Jupyter notebook I have available. All you need to do is just install Kafka Python ng, this package. And once you have this, then you can write code something like this. Code is pretty simple. I have the Kafka producer, I have the Kafka consumer. I will connect to the server, so I provide the local host, and there is the value serializer. If you have the JSON value coming, then you can serialize this value, and then you send the value inside this particular function. Producer.send. You give the topic name and you give the value. It can be JSON or any value that you want. And on the consumer side, I have the same function available where I can just consume the message. Same thing. I have the topic. I have the local host. The offset is set the earliest, so it will start reading the message from the beginning. Okay. Auto commit is true, so every time the message comes, it will commit it. And this is a value deserializer. Over here, we are serializing the value as a JSON, and then we are getting the value and decoding it. So I can just run the consumer here, and same thing, I can send the different messages over here. So as per my requirement, all of the messages that you send will come here. So let's say if I change the name to Akash, okay, and let me just Akash, and if I run this, you will see the name on the consumer side will also come. And if you go to the terminal, you will also see this message available over here. So this is a simple explanation of how Kafka producer and the consumer work. You can just write this stock market data engineering and you will find this particular project. This project has been viewed by more than 250k people, and you will understand everything about Kafka. How do you set up Kafka onto the cloud, from how do you install it from the scratch, and then writing the Python code from the scratch to build the entire project. So if you learned something new from this video, then you can like this video, and if you are new here, then you can hit that subscribe button. I'll see you in the next video. Thank you.